electrophilic aromatic substitution reaction. What about the electrophilic aromatic substitution reaction means? This is one of the organic reaction in which the electrophile is replaced by a mix of some of the hydrogen atom which is present in the aromatic ring system. So that kind of reaction is said to be aromatic electrophilic substitution reaction. We are having a lot of variety of aromatic reaction. One is sulfonation, nitration, halogenation, Friedel-Crafts alkylation and Friedel-Crafts acylation. So these are the example of electrophilic aromatic substitution reaction. In this reaction, from the formation of reactant into product, we are getting some intermediate. Through that intermediate, we are getting some product. So that intermediate is said to be arene ion intermediate. Next, we are going to see about the arenium ion mechanism. So what are the arenium ion mechanism means? It involves two steps. One step is the formation of the unstable intermediate formation. So that formation is said to be arenium ion. So that arenium ion loses its aromaticity. After that, there is a removal of hydrogen atom. It will get again its aromaticity is regained and it will form the product. So these are the main important two steps which is involved in the intermediate, that is arenium ion mechanism. Next, we are going to see about the energy profile diagram of arenium ion mechanism. The first step is the endothermic reaction. In the case of arenium ion mechanism, it loses its aromaticity in the first step, as well as the first step is a slow step and the rate determining step. The second step is a fast step. In this step is a exothermic reaction. So this is one of the aromatic favorable reaction. So the first step is endothermic, that is the aromatic unfavorable reaction. The second step is a aromatic favorable reaction. It is a exothermic reaction. In this reaction, we are getting the product. So these are the endothermic and exothermic mechanism of arenium ion. Next, we are going to see about the reaction, that is nitration reaction. This is one kind of aromatic electrophilic substitution reaction. In this reaction, we are having two steps. The first step is the formation of electrophile and the second step is the removal of proton or deprotonation is occur from the formation of product. So what is meant by nitration reaction? That is the benzene ring which will be reacted with nitrating mixture. So the nitrating mixture is nothing but the combination of sulfuric acid and nitric acid. Both are combined together, we will give the product. So that product is said to be nitrobenzene. Here NO2 plus is acting as an electrophile. So that NO2 plus is formed means it will be reacted with sulfuric acid and nitric acid. Both are combined together, we are getting NO2 plus. Next, we are going to see about the mechanism. In the mechanism, we follow three steps. The first step is the formation of electrophile, and the second step is attack of electrophile and formation of arenium ion intermediate, and the third step is deprotonation followed by the formation of product. In the first step, the electrophile is formed by the reaction between sulfuric acid and nitric acid. We are getting NO2 plus, that is acting as a electrophile. So that NO2 plus ion, it will be reacted with benzene ring. It will form some resonance stabilized structures. So that resonance stabilized structure is nothing but sigma complex. It is also said to be arenium ion. So that arenium ion loses its aromaticity in the second step. But in the third step, again, its aromaticity is regained by means of deprotonation, and there will be some hydrogen atom is removed from the aromatic ring and the electrophile is attached on the benzene ring. We are getting the nitrobenzene. So we are getting the product of nitrobenzene, that is said to be nitration. So this is one of the electrophilic aromatic substitution reaction. Next reaction, we are going to see about sulfonation. In the case of sulfonation reaction, we are using protonated SO3 minus is acting as a electrophile, that is HSO3 plus is acting as a electrophile. So that electrophile is attacked with our aromatic ring, so that we are getting the benzene sulfonic acid as a product. In this reaction also, we are having three steps. The first step is the electrophile formation, the second step is the sigma complex formation, and the third step is the formation of product, that is benzene sulfonic acid. So these are the three types of three steps which is involved in the product formation of sulfonation reaction. Next one, we are going to see about the halogenation reaction. Particularly, we can speak about the chlorination of benzene. In the case of preparation of chlorobenzene, we have to take the AlCl3 as well as then Cl2, that is Lewis acid and Lewis base. Both will be combined together. We are getting some electrophile. So that electrophile is reacted with benzene ring. We are getting the chlorobenzene as a product in the same formula. It will undergo also a 3 steps. One is electrophile formation, second step is sigma complex formation, third step is a product formation. So in this step we are getting chlorobenzene as a product. So this is also comes under the electrophilic substitution reaction. The next reaction is some of the Friedel-Crafts alkylation reaction as well as Friedel-Crafts acylation reaction. In the case of alkylation reaction, we have to take aluminum chloride as well as alkyl halide as a reagent that will be reacted with benzene ring. Both are combined together. We are getting some acylated product that is said to be alkylated product that is said to be or is incorporated in the benzene ring. We are getting the toluene. For an example, we can take benzene that will be reacted with methyl chloride. We are getting toluene as a product. So that reaction is taking place in the presence of aluminum chloride. So that is said to be Friedel-Crafts alkylation. So that alkylation is also comes under the category of electrophilic aromatic substitution reaction. The next reaction is electrophilic substitution reaction is Friedel-Crafts acylation reaction. So in the case of Friedel-Crafts acylation reaction, we have to take a reagent of acyl chloride. So that acyl chloride is combined with our benzene ring. We are getting the acylated product. It is also a Friedel-Crafts acylation reaction. So these are the important 4 types of electrophilic aromatic substitution reaction which is involved in the organic reactions, that is nitration, sulfonation, halogenation, Friedel-Crafts alkylation and Friedel-Crafts acylation. In the above said 5 reactions, same mechanism is followed. The first step is the electrophile formation and the second step is sigma complex formation and the third step is deprotonation followed by product formation. So these are the learning outcome which is obtained from the previous classes. We are studied about what is meant by electrophile and the definition of electrophile. The next one is what are the reaction mechanism involved in nitration, sulfonation, halogenation, Friedel-Crafts acylation and Friedel-Crafts alkylation. So these are about the electrophilic substitution reactions. Thank you.